All right, in this video, we will now look at how to solve absolute value equations. So be familiar with the approach that we're to be using and why we split them into two equations shown in the previous video. So let's get the ball rolling. We have the absolute value of the expression 3x minus 6 equals 42. Now what that means, 3x minus 6 is located 42 units from 0 on the number line. 42 units to the right, 42 units to the left. Now my approach is, do I have to isolate this absolute value? And there's nothing going on to this absolute value. It's completely isolated. There's no addition or subtraction on the outside, no coefficients on the outside. So now that it's isolated, I can split it into the two equations. One, where 3x minus 6 is equal to 42. And the other, where 3x minus 6 is equal to negative 42. And we solve the two equations separately. So I would add 6 to both sides and get 3x equals 48, and then divide by 3, x equals 16. And I do the same thing here, add 6, so 3x equals negative 36, and then divide by 3, x equals negative 12. Now don't think I forgot, because you are always supposed to check your answers. And so I plug it in. And it's as simple as just plug it in. You can even use a calculator if you want. Me, I don't like using calculators. So we have 3 times 16, which is 48, and 48 minus 6 does equal 42. So this one works out. I have 3 times negative 12, which is negative 36, minus 6 is negative 42. Well, is the absolute value of negative 42 equal to 42? Yes, it is. So both of these work out. So x equals negative 12 or 16. Some of you may be wondering, why did you write negative 12 first? It's because I like to write my answer the way it appears on the number line. That's the reason why. You could say x equals 16 or negative 12. I like doing it in the order it appears on the number line. So if we look at example 2, now this one looks more complicated because in this example, my absolute value is not isolated. I have 4 times the absolute value of the expression 2x minus 7 plus 5 equals 9. I have to get that absolute value all by itself before I can split it into two equations. The way you do it, and this was talked about in the solving equations video, is stop looking at the variable when you're trying to solve and look at the object that contains your variable, which is the absolute value of 2x minus 7. I have to isolate that first. So the way I'm going to do that is by getting rid of the 5. So I'm going to subtract 5 from both sides. And so now I have 4 times the absolute value of 2x minus 7 equals 4. Still, the absolute value is not isolated. I have to divide both sides by 4. Get rid of that coefficient. And that gives me the absolute value of 2x minus 7 equals 1. Now that my absolute value is isolated, I can split it into the two equations. Absolute value of 2x minus 7 equals 1 means the expression 2x minus 7 is located 1 unit from 0 on the number line. So 2x minus 7 equals 1, or 2x minus 7 equals negative 1. And again, understand what we went through in the previous video. Whatever's in the absolute value does not change, because this equation, you read it as the absolute value of 2x minus 7 equals 1. I interpret that into the distance of the expression 2x minus 7 is 1 unit from 0 on the number line. And that is how I can split it into the two equations, and why the variable expression in the absolute value bars does not change. You're finding the distance of that object. And now solve them separately. You would add 7, so 2x equals 8. So divide by 2, x equals 4. I would add 7. So negative 1 plus 7 is 6. So 2x equals 6. So x equals 3. And then you're asked to check. When you check, guys, just do your basic plugging in. You have 2 times 4, which is 8. So I have 8 minus 7. So I have 4 times the absolute value of 1 plus 5. So that's 4 times 1, so 4 plus 5, which is 9. Good, so this works. And I have 2 times 3, which is 6. 6 minus 7 is negative 1. So I have 4 times absolute value of negative 1 plus 5. Absolute value of negative 1 is positive 1, so 4 plus 5, which does equal 9. And so this one works as well. So my answer is x equals 3 or 4. So there you go. We split it into the two equations after we isolate the absolute value. So I mean, it can't get any trickier than that, except for when we look at example 3 for it. So if I look at example 3, this is always fun. The absolute value of 8 plus x equals 2x minus 3. How do you solve it? And so people look at this problem and say, well, this is completely different than everything you've done in the previous two examples and how you explained to us, which is wrong. Because all math goes to the process, how you approach the problem. And that's why I don't just think, oh, I get the variable by itself. No, you have to look at how you approach the problem. Is your absolute value isolated on one side of the equation? It is. 8 plus x, the absolute value of that is all by itself. There's nothing to the left of it, nothing to the right of it, so we can get to the solving part right now. Even though it looks like this, it looks completely different. The absolute value is isolated. Now you split it into the two equations. And that's the part where you're like, well, that's different. No, it's not. What's different about it is rather than having 2x minus 3 in the previous problems, I would have 8 plus x, we'll say, equals 9. The absolute value of 8 plus x equals 9. And what would you do in this case? In this case, you would split it into two problems. One where 8 plus x equals 9, and the other where 8 plus x equals negative 9. So tell me, what's different over here? Nothing. It's a variable expression, but you do the positive of the right side and the negative. So when I split this, I'm going to leave it as 8 plus x, drop the absolute value bars, equals 2x minus 3. That takes care of this one. You just leave it alone. Drop the bars, boom, it's equal to the positive. The next one, though, I have to take it and make it so it's equal to the negative of the right side. And so in this case, what that means is I'm going to take the negative of 2x minus 3. But since that is an expression, I have to take the negative of the entire expression. So 8 plus x equals the negative of 2x minus 3. Here, well, why didn't you put a parentheses? It's one object. You don't need a parentheses. But when you have multiple terms and you want the negative of those multiple terms, you're going to have to treat it like an object and put it in a parentheses. So if you look at this left side, this is a lot easier to solve. I would subtract x. 8 equals 2x minus x is x. So 8 equals x minus 3. Add 3. I get 11 equals x. So x equals 11. So check your answer. 8 plus 11 is 19. 2 times 11 is 22. Is 19 equal to 22 minus 3? Yes, it is. So that answer works. And so now we look at this one. Well, before I can solve, I have to simplify that right side by distributing the negative. So I'm going to get negative 2x plus 3. So I would add 2x to get over to the left side. So I get 8 plus 3x equals 3. I would subtract 8, and I get 3x equals negative 5. So x equals negative 5/3. And that's what we get on the right side. So now we have to go ahead and plug it in and check our math. So luckily I saved myself some room over here. I have 8 plus a negative 5/3 in an absolute value. So 8 minus 5/3 from it equals 2 times negative 5/3 minus 3. Well, 8 is 24/3. So 24 minus 5, I have the absolute value of 19/3 equals negative 10/3 minus 3. So negative 10/3 minus 3 is going to be, 3 is really 9/3. So negative 10 minus 9 is negative 19/3. So the absolute value of 19/3 is a positive 19/3. So does 19/3 equal negative 19/3? No, it does not. I plug in negative 5/3, I'm going to get the wrong answer. I'm not going to get a true statement. So this is not part of the answer. It is an extraneous solution. I did everything right mathematically. This is not a trick. You did this right side perfectly. The negative of the expression, we distribute it. We move the variables to one side. We got the variable by itself, and we solve for x. However, the answer, when you plug it in, yields a false statement. That is why it's extremely important in this unit. You always check your answer for extraneous solutions. I hope you find that helpful. And the next video we look at is dealing with